Welcome to Brain Vision.
In this question, we have the following forces in action. So we have the weight force of the clown, we have the normal force that the ground is exerting on the clown, we have the force that the clown is exerting on the rope, and then we have the rope answering that force F with a tension T. And then that tension T is transferred to his feet. Moreover, there is also the frictional force that tries to keep the clown in place. Then we have to calculate what is the minimum value of this force F that is necessary to make his feet move. So what is the minimum value of F such that this force can be bigger than the frictional force? In order to do that, we have to apply Newton's second law. And I think that we will need to apply it in this axis, the vertical one, which I will call Y, and on this axis, which I will call X, the horizontal axis. We begin by applying the Newton's second law to the vertical axis. Then, on the vertical axis, Newton's second law tells us that the net force is equals to the mass of the clown times the acceleration of this clown. The acceleration is equals to 0 because he is standing still on the ground. Then the net force on the Y direction is equals to 0. But the net force on the Y direction is composed by three forces: T, normal force, and the weight force. These are the forces that are acting on the clown. The force F is a force produced by the clown, so it will not enter in this equation. In this equation, we will only use the forces that are acting on the clown. Then we have that the tension force plus the normal force minus the weight force is equals to 0. Then we have that following relation: T plus N is equals to the weight force, and the weight force is equals to 809 newtons. Then we know a relation between the tension force and the normal force. Now let us do the same thing but for the x-axis. So on the horizontal axis, the net force is also equals to the mass of the clown times his acceleration. Again, he is standing still, he's not moving yet. Then this acceleration is equals to 0. So the net force is equals to 0 on the horizontal direction. But on this direction, the net force is composed by two forces: the tension force and the frictional force. Then the frictional force, which is pointing to the positive direction of my horizontal axis, will have a positive sign. And then we have minus the tension force, and this is equals to 0. Now we can solve for the tension. So the tension is equals to the frictional force. Now, what is the maximum value of the frictional force? So we want the limit situation. So for the limiting situation, we have to calculate what is the maximum value of the frictional force. And we know that the maximum value of the frictional force is equals to the static frictional coefficient times the normal force. Then, in order for the clown to be almost moving, we have to have a tension that is equals to the frictional static coefficient times the normal force. And then we have to calculate what is the value of the normal force. And to do that, we can go back to this equation and solve it for the normal force. By doing that, we get the following. The normal force is equals to 890 minus the tension force. Then we can use this result in this other equation and solve it for the tension. So the tension force is equals to the static frictional coefficient times the normal force, which is 890 minus the tension force. Then T is equals to 890 times mu s minus mu s times T. Then we can send this term to the other side to get T plus mu s times T is equals to 890 times mu s. So we factor out the tension on the left-hand side to get T times 1 plus mu s is equals to 890 times mu s. Finally, the tension is equals to 890 times mu s divided by 1 plus mu s. but mu(s) is equals to 0.53. Then the tension force is equals to 890 times 0.53 divided by 1 plus 0.53. This results in a tension of approximately 310 newtons. So this is the tension force. But according to Newton's third law, the tension force is a reaction force, and it's reacting to the force that is applied by the clown. Therefore, the force F should be equals to 310 newtons in the limiting situation. So F must be bigger than 310 newtons in order for the clown to be able to move his feet.